All right, let's get started. I'm going to bring my guests on right now. Here we go. All right, welcome, Viktor. Welcome, Whitney. How are you two doing today?
Always great. Immutably great.
Awesome.
I'm wonderful. So happy to be here. I'm grinning ear to ear like a child. Sai, I used to watch your videos. Watching your videos was my first exposure to Kubernetes. So I just can't believe I'm here.
Right. Whitney and I used to actually do these at IBM. You guys might have seen some of the videos we did with the OG Lightboard. So we see folks tuning in. Drop a message in chat. Let us know where you're tuning in from. Let us know, whether you've seen some of our videos before. We've got Viktor here, the star of the popular YouTube show, DevOps Toolkit. Whitney, of course, star of Enlightening. And myself here, hosting containers from the couch. Very quickly, let's go around. Tell us a little bit about yourself, Viktor. Tell us a little bit about what you do.
Oh, that's what I do is impossible to explain. So the closest I've been able to, the simplest way to explain is that I do random stuff, and then sometimes some of those things end up being useful. So I work in a company. I was software developer, tester, I was team lead, project manager. Now I'm a developer advocate, and Upbound. And on top of that, I have a YouTube channel and a podcast. And I don't know what I have, random things.
Well, Viktor, something you're doing is correct, I guess, with enough randomness, but love your channel, love your show. And, especially being an Upbound today, of course, the creators of Crossplane, core to the technology we're going to be talking about today to help serve internal developer platforms. More on that in just a minute. Next, I want to jump to you, Whitney. Same question.
I'm a developer advocate at VMware. I also live in Austin like Sai, and I also have a Lightboard studio in my house like Sai. So I have a streaming show called Enlightening where people from CNCF come and explain CNCF projects to me. I just did an episode this morning on Schema Hero. And then Viktor and I host a show together called You Choose that is such a joy to me right now. It's one of my favorite parts of the week. And it's a choose your own adventure style show through the CNCF landscape where we pit different technologies against each other and come up with a winner.
I was waiting for the laugh. She's a laughing lady, known as a laughing lady.
We got a comment, this lady laughs too much.
What? That's the best part. Come on. All right. So I did drop a link to their latest show called You Choose. I've watched it. It's honestly awesome. Your thumbnails, by the way, are on point. I wish I had even a fraction of your artistic capability with it, but really awesome stuff. Okay, without further ado, folks, I do want to go ahead and get started. Let's start with something that I think is critical and fundamental for really anyone who's just using containers or Kubernetes to understand. And the reason I want to start with this is because it's I think core to understanding how IDPs work. I realize I still got the music going. Let's turn that off here and really
you killed the mood, man.
The vibe.
There was a vibe in there, right? It was nice, huh? I should consider just letting that go next time. Okay, I've got myself on the big screen here. Let's get started. That first thing I want to talk about is the control loop, the Kubernetes controller mechanism. Now, this can be described in a number of different ways, but I'd say the first phase here is setting desired state. So I'm just going to write that as desired. Now, first, when we talk about YAML and Kubernetes, we know that it's driven from kind of declarative YAML. This allows you to set a state and then let someone smarter than you that's written the steps behind the scenes take care of it, right? I'd say it's similar to getting in an Uber or taxi, telling the driver where you want to go, versus getting in your own car and making all the turns yourself. I'd rather just tell someone how to get it done. That's the kind of flow we talk about today with the desires, right?
I have a friend who goes to Uber and then starts explaining him where to go because he thinks that he's better.
Huh. See, that's when you lose faith in your infrastructure as code, and you start going in there and running manual ClickOps, right? That never works well. Okay, so you set the desired state. Next, something's got to actually act on it. Okay, you guys know what this is. What is it usually that's acting on that change in the world of cloud native? It's Kubernetes. Come on, guys.
Okay, I wasn't sure whether it's a question for me or the audience. Okay, so it's me, it's us. Yeah, it's Kubernetes. I mean, the major thing I would add, and I should have prepared, probably I didn't, but it's really acting continuously, right? It's not do this now.
Let's say that then. Let's say, wow, that marker does not work. Pink is letting me down. So let's say continuously converging.
Exactly.
So it's always running. This control loop is always converging what's desired, and it's acting on it. And of course, we're going to have one step here where we're just getting some data from the system. We're observing what happened. Let's just use blue for this. Say we call this observe. Now, I find it critical to start with this because really this is the flow that developers want to use, operations teams want to use. They, regardless of who it is within a company, they want to leverage this kind of automatic, always happening control loop to set some desired state and expect something to happen. Now, today I want to start with a persona. We'll start with the developer. And this developer, let's make sure I'm in the frame. Now, developers, I hate to say it, but sometimes can kind of be compared to like petulant children. Like, I want this, I want that, and I want it to be easy, right? So, and I think I could say that because in the past life I was a developer. Okay, not too long ago.
Well, and what they're saying is, I want to be able to do my job well, the thing I'm tasked to do, and I don't want to fool with this other stuff that has nothing to do with my.
Let's be clear. That's not really limited to developers. Everybody. I go to Amazon and I say, I want the gong, and I click a button and it arrives. So, and I have no idea how that happened or why it happened, but it just happened, right? So it's not limited to developers.
That's right. Okay, so our dev, let's say that they want a few things, right? And Victor, help me out here because you're going to be doing the demo for us.
Okay.
So one of the things, let's say the developer wants
cluster,
an EKS cluster. Right?
Exactly.
Okay.
You need to run an application somewhere. Let's say that's EKS cluster.
Yep.
You probably need a database for that application as well.
Okay. Let's say, like RDS maybe, Aurora, something.
RDS.
Okay, RDS it is. All right, so we've got RDS. And then, okay, as a dev, I want this to be done in a GitOps way. I've heard all the greatest things about GitOps. I've heard DevOps is dead, and I want to do this the GitOps way. And so that's my last request here, Victor. Is I want this all to be managed in a GitOps way. Again,
exactly.
And
even if you didn't hear about GitOps, you're a developer. Where do you keep your stuff?
Yeah.
Right. There's only one place.
Now? It's Git. Am I right?
Exactly. Okay. There we go. Right?
All right.
So even if you don't know about GitOps, that's a natural place where you go. I brought this something, whatever that something is. Doesn't matter whether it's Java code, Go code, YAML, JSON, XML, whatever you wrote, you put it to Git.
That's right.
It's as easy as that.
That's right. Okay. So dev wants this, and we've talked about this control loop. So this is desired, but it's not a state yet. We haven't put it in Git, and we need to do that first. So let's put the dev aside for now. We understand what they want. Let's build the backend that this dev is going to be using. And so I think the first thing to start with, and it's what you asked me, Victor, is where do they store, where do devs work with code? And it's the same place that we want, operations engineer to work with automation code. It's not on a folder somewhere on their laptop, or if it is, I think you need a new ops engineer. It's in Git. Right. So let's put a box here and we'll call this not actual, desired state.
Desired state, yeah.
So what goes in the desired state, Victor, Whitney?
No.
It's what's in the desired state in Git, and we'll even write Git out right here.
So it's the real question is, so the desired state is what I want to have. I don't care how. I don't know. I mean, I don't care that much even when. I just want to have this, like the gong that I mentioned, right?
I'm not
That's
writing
the
that.
desired state. But
So-
we have a problem there with desired state is if I cannot describe what my desired state is, then we have an issue, right? Like, for example, I can easily say I want an EKS cluster, right? But will I, as a developer, be able to say, okay, so the node group and a VPC and a subnet and internet gateway and so on and so forth. There are a lot of things required for a very good reason. We have to have those things. But I have no idea what those things are.
Right.
And we don't even have to go into AWS for that. I can say, I want an application in Kubernetes. What is an application Kubernetes? Nobody can ask that question because, it's ingress and a service and a virtual service and 57 other things.
So this guy doesn't care about that. This guy just wants an
Nope.
EKS cluster. He doesn't care about
Or
setting
she.
up the IAM roles and the policies and the subnets and the 15 other things that you need to get a production-ready cluster with storage running GitOps.
Exactly.
Okay, so we're going to get to the actual, because we don't really know what that is yet. All we know right now is that we have some things that are desired. And in the world of Kubernetes, we set desired state for apps using manifests. So let's at least start with that. Let's say manifest. Now, what about code? What about applications? That also is going to be something that lives in Git. So we've got code.
Just to be clear, though, probably not the same repo as all the configuration.
That's a good point. So generally, you'll have an idea of a configuration repo versus where your actual apps live. And then your apps, devs are really opinionated in the way they do this. Sometimes they put all their microservices in one Git row. Sometimes they break it up by which team works on it, which individual works on it. It's really up to them. But the idea here is that maybe I should make this plural, Gits. I don't think that's the real word, but Git repos, where you're going to have all the things that you have desired that can be stored in Git. And then let's just add one more here and say configs. We'll close this box off. Okay, so we have an idea of what we have in desired, and we have an idea of what we really want. Well, we haven't really drawn this out yet. Maybe let's do that. I like to work bottom up. So today in Viktor's demo, he's going to be showing how you can use Crossplane to work with AWS. I'm going to try my best to draw a cloud here. Decent. What do you guys think?
Amazing.
Yeah.
Yeah? You think like solid 7 out of 10? I don't know. Something. All right. And next on top of that, we're going to continue to build this out. So that's kind of the service provider. We need some infrastructure on top of that. And here's where we get the pieces that we wanted. So let's start with the EKS cluster. And we'll also say RDS. The markers are dying on me. Okay. And lastly, on top of this, we need some running applications. So I'm just going to draw these as containers. Let's not get too specific, but the idea is the dev's going to run some code on top of that. So here's where we want to get to from here to here. Now, Viktor, say 5, 10, 15 years ago, let's say we're working with not EKS, but EC2, and we have our Java EE application, and we want to build a pipeline to get from here to here. How would you do that?
So most likely you would have some webhook firing into some process, and that process typically would be what people call CI/CD, I call pipelines. Jenkins, I don't know.
Okay.
Or Tecton didn't exist 10 years ago. Let's say Jenkins, right?
Jenkins,
For
all
the
right.
sake of CI/CD pipeline.
Okay, let's just say CI/CD. I'm going to put this in a box, and we're going to call it tools. And let's draw a big box around this, and we'll start building this out. But I'd say the old school, and we're going to call this the DevOps way of doing things, would have been to set up some sort of webhook that pulls from Git, that does that continuous integration flow, kicks off a build in something like Jenkins or Travis or whatever it might be, and then that'll kick off the actual build. Now, that's not following the control loop mechanism. The mechanism that really, I believe, is one of the core reasons why Kubernetes is so powerful. There's no real controller here making sure that this matches the state of this, right? Because at the end of the day, we want Git to be the source of truth. Your dev can go to Git and know for certain that this matches that. And unfortunately, although you could get very close, the traditional tools didn't necessarily help us get there. I think this is a point of contention because a lot of people say you can do GitOps and you can do control loop with these old school tools. Victor or Whitney,
we're going to have a fight now.
Yes.
Because Open GitOps defines four bullet points that need to be fulfilled for something to be called GitOps, whatever that is. And two of those are pull-based mechanism. What we are describing now is from desired state to CI/CD tools. You're triggering a process out, right? And the second one is continuous reconciliation. So that means that, in that circle you have in the top right corner, at least from my perspective, that one. So we are skipping the bottom part, right? Which is essentially one of the components of GitOps. And
that's right.
The push-based mechanism is problematic for at least two reasons. First is that you need to have permissions to access something, right? So if I want to deploy something to that EKS cluster, I need to have credentials to do that. Not extremely secure, right? And the second problem is that when I push a change to that Git repo, right, something will happen. That CI/CD pipeline will do something and something will happen and I'll get some state, whatever the state is. Whatever happens after that is going to start the differentiation between the actual and the desired state. Because that application might go down. And then what?
Exactly. So the idea of config drift, right? So someone pushes something to this, the CI/CD tool picks it up. Maybe the second you did that build, you know for certain that the desired state matches the actual. But what about the next day or the day after that? What if some engineer went into the actual cluster and turned a bell or a whistle one way or another? Now, suddenly, we have something called config drift, and the tools know nothing about it. They have no idea that changed. And that in essence, I think, is a critical problem with kind of the old school way of setting up these webhook push-driven pipelines. Fair?
Yep.
Correct.
Okay, so how do we solve this? What's the magic tool to help us configure this in a GitOps-centric controller mechanism way?
Kubernetes.
Yes. Okay. Awesome.
I thought you were going to say GitOps.
Yes. And what?
GitOps isn't really a tool, though. That's a methodology.
That's right.
Yeah.
Category of tools.
Okay. Category of tools. That's more accurate because it's not just Kubernetes that does it. It's a certain tools that we're going to get to that are really going to make it happen. But
Actually,
Kubernetes is the first step.
I will argue, so I'm giving you a hint now, Sai, that later on I will argue that neither GitOps tools nor Kubernetes alone are making sure that the desired and the actual state are the same.
Right.
Neither of the two.
Well, So if it's not GitOps and it's not Kubernetes, it's not GitOps tools or Kubernetes, then what could it be? Because this is data.
Alone.
This is actual state. This is desired. This is what state you want. The tools are facilitating, pulling the data and actualizing it. And Kubernetes is keeping everyone honest.
So here's the story, right? You define a desired state. Whatever that is, it's in Git. And one way or another, with, let's say, GitOps tools, with Flux, you make sure that what is defined in Git is the same as what is in Kubernetes. So far, so good. But here's my question. Is Kubernetes or the resources in Kubernetes, are they the actual state?
No, they are the running capabilities, but the state of those is parsed. It's observed.
Yeah, because that actual state is realistically a container if it's an application. It's an RDS database if it's a database, or it's a different Kubernetes cluster, EKS, right? So those are the actual state. Those are the real physical something running. A deployment in Kubernetes is an abstract model that ultimately leads to containers, right? So when you say GitOps created the actual state, hence created and makes sure that deployment is there, that's not the actual state. The containers are the actual state. So you need to combine the two, or some other tools to get from A to B.
Exactly, and that's where tools like the ones we're going to talk about today, including Flux and Crossplane, and I think there's a couple of others that actually facilitate taking the data from the desired state and running some API calls to make it the real thing. So I want to finish drawing this out here. So we've got the tools, and the missing piece of the puzzle here is Kubernetes, and specifically in this Kubernetes cluster, Crossplane leverages custom resources and custom resource definitions, right? So let's just sketch that out here. Let's say we've got some CRs and some CRDs. And in this Kubernetes clusters, these custom resources are waiting. They're ready. The definitions are ready for custom resources to get created, which will enable Crossplane to use a provider. Actually, it's probably worth drawing that out. In the context of Kubernetes, we have something called a provider in Crossplane. Crossplane here, which is actually going to translate the calls from whatever tooling we're using into actual things in AWS.
And to be clear, every custom tool you add to your cluster is going to use custom resources and custom resource definitions, not just Crossplane. And which actually, I have a question about just terminology about what we were talking about before. So when we say GitOps tools, do we mean, is Crossplane considered a GitOps tool? This might be a question for Viktor.
No.
So we're talking about Flux or Argo CD as a GitOps tool.
Flux and Argo CD, yes, would be. There are 4 tools in total. Nobody yet showed me the 5th one, and Flux and Argo CD are those. There is Cap Controller and Rancher Fleet. There we go. Right.
Okay.
So essentially, what they do is they make sure that whatever is defined as Git becomes a resource. Doesn't matter whether it's a baked-in Kubernetes resource or custom resource. Those CRs are essentially in the same state as the manifests in your Git repository. That's their goal, and they would run continuously, making sure that it's always like that, right?
Right.
One thing that I would add, now that you mentioned provider, so far, essentially when you install Crossplane provider, let's say AWS provider, right? It installs one-to-one CRDs to AWS resources. So if there is close to 1,000 resources in AWS right now, correct me if I'm wrong, give or take, you would give or take, meaning that we might have missed something, but give or take, you get 1,000 CRDs installed or created when you install in an AWS provider, right? And they match one-to-one. EC2, EC2, EKS, EKS, RDS, RDS.
There's a problem there, right? It's when I think this is a whole different discussion, but you can have too many CRDs. Like that can start affecting the how effectively your cluster operates. And this is one of the problems I believe we've been trying to solve.
It's a huge problem. Kubernetes itself is not really prepared on average, without now going to details depending on specific Kubernetes. Most Kubernetes is handle around 500 CRDs without any hiccup. Anything beyond that starts creating problems.
That's right.
And that's one of the big issues with Crossplane. We're working with Kubernetes.
I'm that one to you. Let us know when you fix that problem. We'll get back to you soon, okay?
Exactly.
But no, it's really something that I don't know. I'm curious to see what the solution is. Maybe it's limiting the CRDs to the actual resources you want to use. Maybe there's a more graceful solution that we come up with. But I think for the context here, I want to move to the next step. We've talked about basically all the pieces, but Viktor, should my dev know how to use Crossplane and all these tools and then set up their desired state and manage this entire flow? I mean, it's DevOps, right? It's all one thing. So the dev should be doing ops, right?
They should have an interface that, a single interface that helps them do whatever they need to do, whatever that something is.
And I wonder what that's called.
And that helps them do it with the lowest amount of cognitive load possible for what they need to do.
Yes. And so I'll draw that right here in between, and that's going to be the internal dev platform. Now, what exactly is this? How does this materialize? It could be an API, right? It could be a UI. I know there's some solutions in the ecosystem that are being built to handle this. Can you talk a little bit about what you're seeing for companies out there that are building these platforms?
So at least among companies that are doing it right, and by right I mean treating developers as customers, meaning fulfilling their needs, not somebody else's fantasies. It really depends on what people are comfortable with, right? Because that can be, hey, all I want to do is push to Git. Excellent. There you go. Zero effort, right? I want a web user interface. I want an API that will help me do that, and so on and so forth. So I tend to put an IDP as a very wide umbrella because it really depends what people are comfortable with. But we have a tiny problem that I'm not sure when we should tackle, and that's the words that you have above the IDP right now.
Yes. Let's talk through this flow. We've drawn out all the pieces, but we don't actually know how everything fits together. So I think it starts with the dev. This is his checklist. Here's what the dev wants, right?
Can I now argue that actually that shouldn't be developer's checklist? I would argue that developer really wants a Postgres database and a Kubernetes cluster.
Yeah.
Right?
Yeah.
And it is an implementation detail that Kubernetes cluster becomes EKS and that Postgres database becomes RDS, because there are people who understand performance and understand infrastructure and so on and so forth. And yeah, this is how we run Kubernetes. But from my perspective as a developer, hey, Minikube works, right?
Yeah. So realistically, the idea here is, look, dev have use cases in mind. They want results, they want goals that they want to hit, they're being told to hit, and this is how shadow engineering arises in companies where devs that aren't given enough structure or direction on the way to do things will end up just doing it however they want. And so you'll end up, this is actually the most natural way that companies end up multi-cloud, because they don't have an internal dev platform requiring them to do one or another. They just do what they want. And then it ends up, oh, now we have 4 different apps running on 3 different clouds. So with the internal dev platform, okay, here's where the opinion set. So, okay, we'll ignore this. We'll say the dev goes to the internal dev platform. And the internal dev platform says, okay, you want a cluster, you want database, and you want to do this the GitOps way. And so they click, or they call APIs. And then now this bit gets kicked off, right? So this internal dev platform is going to go ahead and create the Git repo, And then we have all this stuff behind the scenes that the dev has no idea even exists. This is an implementation detail. It doesn't matter to the dev whether it's Crossplane or Terraform or whatever it might be. The point is, this is something that the ops team has created to make this flow easier for the devs. So the internal dev platform creates these pieces. And now that that's set, whenever they want to make a change, so they want to configure RDS, they want to configure the cluster, they go directly to Git, right? And this is something that devs are familiar with. They want to use Git. Here's where they store their code and their manifests, their configs, and that kind of thing. Am I good so far, Victor, or do we want to?
You're excellent.
Okay. Now, help me out. So we have the desired state, and we have the tools, and the tools that you're going to demo for us today include Flux and Crossplane specifically. So we're going to be using Flux and Crossplane. And what happens next? How does this know that something happened here?
So Flux would make sure that those manifests are in the same state in that Kubernetes cluster as in Git, right?
Okay.
So Flux would do the synchronization between the two.
So should I draw like a two-way arrow here? So it's reading from Git, and Git is publishing what might be like a webhook, and this is continuously configuring to make sure that that's in the right state.
Yeah, exactly. Those two arrows, and then another two arrows between Flux and Crossplane or Kubernetes.
Yes. Okay, here we go.
Between Kubernetes, exactly. So I read one. Okay, so this is what is in Git. I go to Kubernetes. Or you're already running Kubernetes. This is what it is. What's the difference? And if there is any difference, let me make sure that there isn't.
Right. And now, what's the role of Crossplane here? So it reads the manifest and the config that's stored in Git. Let's say that they've created some compositions that enable them to create a cluster, an RDS, along with their sample code. They push it, Flux applies it. Now, what's Crossplane's responsibility here?
Can I jump in
Go ahead.
and make? I'm going to make it super. I'm going to oversimplify things like I do. But what's happening is you need a Crossplane resource. Is what's defining what's defining what's happening in your actual state. So you're using that CR in a box. That's what's going into your Git repository. You're defining what you want that custom resource to look like in Git.
That's right.
Does that make sense? And that's what's getting reconciled.
So I should probably write here, this config is really, I think in Crossplane terms, a composition, right? And that's a custom it becomes a CR, a custom resource at the end of the day. But it's recorded, the YAML file is a composition, and it abstracts away all the different complex stuff like the subnets and the VPCs and all that. We just give them, the developer, the things that they care about. So maybe they want one cluster with 2 nodes, like minimum 2 nodes, and they want it to be, let's say, using GPU optimized instances. So they have a flag for that. And so they set up the composition. They don't have to worry about setting up all the complex stuff. This is what kind of translates that composition into all the actual things that exist.
So essentially, it's a two-step process, right? Flux created a custom resource called my cluster, right? Or my Kubernetes cluster. And that's a composition. And then Crossplane takes that and says, okay, whomever designed this new interface designed that my cluster should be expanded into EKS and a node group and VPC and whatever else we need, right? Implementation detail from user perspective. I said I want a cluster, but Kubernetes creates from that resource a number of other resources that are matching one-to-one what should be created in this case in AWS.
Right.
And it goes there, creates all that stuff. And it makes sure, so Flux from here on is making sure that CRs and Git are the same. And then Crossplane takes the second half of the journey and makes sure that whatever those CRs are is what is in AWS, right? The moment something in AWS changes, Crossplane will update it. The moment CR changes, Crossplane will update it. So if you can think of GitOps as in this context, as 3 steps. Git The final step would be AWS, and then intermediary that is making sure that all that is happening is Kubernetes extended in this context with Crossplane.
Correct. And realistically, with Flux, for example, you would extend this Kubernetes box over this entire section because everything is running in this Kubernetes cluster. And so really
Correct.
what we've drawn out here is actually the same thing we started with, but in more detail. We've got this entire control loop, the desired state, the actual state, and then this continuously converging piece. And this is always running at all times. And so that config drift issue we talked about earlier, what happens if some developer comes in here and changes some bell or whistle in this? Well, it's going to know immediately, and it's going to try to reconcile that. And it's probably just going to say, oh, that's wrong, and might throw an error, and it might just go and redeploy it. Hopefully, if your stuff is all immutable and deployed correctly, nothing will ever, no applications will ever go down, ideally. But that's the idea here, is that with this continuous convergence, your actual and your desired, you can be consistent and confident knowing that they match. And I think that's a critical aspect to why GitOps is different than maybe more traditional DevOps approaches. Okay, now we have about 20 minutes left here. Victor, I know you could do a demo in 15 minutes. I saw you do it on PlatformCon 22. But let's switch scopes here and see if you do it for us today. I know we've got an exciting demo helping folks understand how to actually materialize some of these abstract concepts we just talked about.
Yep. Can you bring my screen?
You got it.
Oh, there we are. Okay, brilliant. Okay, so no, wrong screen. Okay, wrong screen. Wait. I need to. No, I don't want that. I want this. I'm unprepared. There we go. Okay, so here's a definition, right? And this definition is that Crossplane composition. It says, hey, if you want to create a cluster, you need to create something called cluster claim. This does not come out of the box Crossplane or none of those things. This is somebody in my organization extended Crossplane, created a composition that says whenever somebody wants a cluster, all you have to do is to define cluster claim. You can use labels to decide what is the variation you want. In this case, I want EKS cluster. Some parameters that will fine-tune your experience. And those parameters are what we agreed. You told me what you care about. Those are the parameters you can deal with. The things you don't care about are hidden from you, right? So here I'm saying node size medium. I, as a developer, I might not know that I should use T2 something, T2 medium, or whatever the sizes are. AWS not my problem in this context. I want medium, small, or big nodes. I want to start with 3 nodes, and I want Kubernetes 124.
Hey, we
finally,
just 125, by the way. Sorry, Victor. We've got to make that.
Oh, my bad. My bad. And I want to be able to connect to that cluster, so I want Crossplane to write a connection kubeconfig, essentially, to the secret called production cluster, right? That's what I want. Now, how am I going to get that? Well, I'm going to add that file to the Git repo. I'm going to commit that file. I'm going to say cluster, and I'm going to push it to Git. That's it. I'm finished. As a developer, I don't care anymore. That's it. I'm done. You should imagine that I might have some dashboards, and probably I could see the state of that cluster in maybe Backstage, maybe some other dashboard. And now, or I like using kubectl, or I change the role to be an operator, and I can say, hey, give me the namespace, Flux system. You can now guess what I'm using to synchronize Git with my management cluster. And I want to see all cluster claims. And there we go. 9 seconds ago.
Dev do this, Victor, or are we seeing what kind of the ops engineer behind the scene would be inspecting?
Depends. Now, that goes back to the previous claim that I said. Depends what people are comfortable with, right? If a developer is comfortable using kubectl, hey, why not? Go ahead. If you're not comfortable, then you would go to Backstage. Maybe that would show you information by querying the API of Kubernetes and showing you some information like what are all your clusters, right? Now, even if there's this separation also. If I would say use directly Kubernetes, which I wouldn't to developers, but let's say for the sake of argument, I would. This is what the developer would see, right? Now, you as an operator, doesn't matter the format, whether this is from terminal or from a web UI or something else. I'm talking more about information, not ways. You as a developer, you would see demos sometimes fail. Let's see. Come on, Whitney, tell us a joke.
What's brown and
Okay, there we
sticky?
go, right.
Oh.
This is what really happened. Too late, Whitney.
I don't know if I want the
There is-
punchline to that joke. I don't know if it's appropriate.
So the result of you defining something like this, what is something that you understand, the result of that is actually that we got a cluster claim. This is what you see, this is what you created, but behind the scenes, we got some Helm chart that will be installed in that cluster. We got some Kubernetes resources that will be created in that cluster. We got a route table, subnets, route table associations, main route table association, security group rules, internet gateways, route, security group, VPC, and so on and so forth. You would get a bunch of resources that are not really your concern, but are absolutely necessary, right? And that's that relation that you have between a developer consuming a service, meaning this, and somebody providing that service internally to that developer by defining what this means, right? Now you said I can do it in 15 minutes. I did it in 5.
Oh my gosh. Okay.
I can show more.
Let's see more. Okay, so just to kind of level set here, what we saw here is, the first thing you showed was let's just actually create the claim, and you get the cluster. But you were just interfacing with Git, and most developers are happy to do that. They're happy to interface with Git. If you tell them to go into this cluster and search up the composition and debug the creation, they're going to say, get out of here. That's not my job. You should do this yourself, right? So I'm guessing the context here shows both sides of the picture, but the dev really just does that easy bit with Git. And then in the back end, here's all the stuff that the ops team manages. So realistically, this enables them to scale to not just one developer's request, but all the dev teams within their company can now start using this operational cluster to deploy whatever resources it is they need, right?
Once that cluster is created, can you continue to manage it using that claim?
Yeah, so I could do something like this and say,
nodes.
hey, I need 25 because CM just told me that they released it. I push it to Git, and now nothing would happen because I might be wrong, but I think that it would need to wait until the cluster 1.24 is created, and then it would update it. So it would do the update when it's safe, where it can be done, right? But what matters is that I just made a change. If I would push it to Git, Flux would synchronize it with my management cluster. That would be a new updated claim in my cluster. Crossplane would create all the resources or update all the resources required for that. And ultimately, where is it? Crossplane would change the definition, in this case, of cluster and node groups, and propagate that and communicate with AWS to make sure that, oh no, it's 125. That's what you wanted. Now,
Right.
One quick thing I thought to show, just very quickly, without doing any commercial.
Hey, Victor,
Where are
real
we?
quick, while you show that, I realized my laptop stopped charging. So, Whitney, I'm handing you the reins here. You're now host of Containers from the
I
Couch.
got you. I'll put it. Let me update my LinkedIn right now.
So, if you were wondering how you can create that claim in the first place, you can just go to the documentation, either in a web UI, or you can do kubectl explained to tell you the same. Any way you want to pull the information from Git and say, hey, whenever you want to work with this resource, this is the specification you need to write, and off you go. That's it. Now, Whitney, you're the whole. Oh, he was quick.
Oh, I'm back. We're not on fire. Okay, we're good.
So that you just showed us how, if we wanted to write our own composite claim, how the documentation we would use for that. Yeah, cool.
Yeah, exactly. And again, that's one of the big advantages of Kubernetes is that, first of all, it's extensible API, meaning that I can extend Kubernetes to define whatever I want, like cluster claim that I showed before. But also, whichever is the interface that works for you, you do not need to hard code values anymore. And say, let's say you don't have to go to Backstage or whichever web UI you're using and say, okay, so whenever somebody wants to create a cluster, they need fields X, Y, Z. Instead, you can just go to Kubernetes and ask, okay, so what is the schema of that something? Here's the schema. And then you just draw that schema in form of fields, if that's what you prefer, on a screen, right? So everything is dynamic, nothing hard-coded. You just need to communicate with Kube API to find out what you can do and what you cannot do.
That's right. And so I would be remiss if I didn't mention a team here at AWS has actually developed some compositions for using Crossplane on EKS. And they call it blueprints for Crossplane. I'll drop a link in the chat here, but this, even if you have no experience with Crossplane, you don't want to create your own compositions. Some smart people at AWS have created them for you. It's an easy way to get started. These are essentially the custom resources and custom resource definitions you can deploy into your cluster, and then really you just have to start making claims against these composite resources. That makes things just a bit easier. Oh, link is not working. Don't copy the blueprints on Crossplane part. Just the GitHub piece. Maybe that should work.
One thing I like about this solution, I like the clear separation between operations and developers. I like that developers don't have to worry about any more than what they absolutely have to. But then I also like that there's room for it to be organizational specific. So you can write a claim that's specific for a certain app team and a certain application instead of trying to wield some tools to make it work for you.
That's right.
So, in most bigger organizations, at least those that I'm in contact with, right, they have their specifics. Whatever is specific for my company. So when we use AWS, it needs to be like this and that. Those are the restrictions. Those are the rules. This is how we do stuff, and you need to follow it, right? And then there is some other stuff that you have freedom on. And that allows you. Now, what would be happening in the past, if you would now delete that board, in the past, the whole process would be very different. The whole process would be, I'm a developer, I need a cluster. What do I do next? I open a Jira ticket and get it assigned to somebody who I never met, right? Mm-hmm. And that somebody is going to work on that Jira ticket sometime in the future, and eventually, if I'm lucky, at an unknown point of time, he will do the job for me. Or she, and close the ticket, says, here's a cluster, right? Now, what this allows is enabling people to be self-sufficient.
It's the same thing, by the way, that AWS did back in 2006, right? With EC2. It's
exactly.
You don't want to call someone up to start up a VM on a data center. You don't want to manage your own data center. It's a whole model with cloud service providers. It's making things self-service, but of course we add some boundaries and guidelines. And then within companies, they need their own boundaries and guidelines, security guidelines. And here's where that internal dev platform really comes in. It's a way for the company to determine and define, here's the tools you should be using. But it's a two-way street, because the devs also benefit from not needing to formulate their own architecture every time they need to simply start developing an application. I know this from my past life. Again, it's that first step of, hey, you have your goal, you have an app you want to write. Well, how do I get started? And then it's sifting through internal wikis, approved platforms and vendors and solutions and purchase orders, and you know how it is. It's especially the larger the company gets, the harder it is to actually do something. And really, devs don't want to do that. They want to focus on writing code, getting their outcomes.
I often use actually AWS as example when people ask me, hey, how does that dynamic between devs and ops, and I'm generalizing now devs and ops because that can be many different specialties, how does that work? And I use AWS as example, right? Imagine that you send an email to AWS saying, I want a VM. You would get no response because AWS worked hard to enable you to get a VM by yourself, right? There is a service for that. You should do the same thing for your customers, right? You should figure out how you can enable somebody to consume your services instead of requesting you to create those same resources. It's as easy as that.
Yeah.
I mean, it's not easy, but
I think
logic.
Exactly. And look, Viktor, I think we've been a little bit too jolly, too happy, too merry with each other. I want to end this thing with a fight, okay? So
okay, let's do
here's
it.
a question for you. I hear a lot of buzzwords out there right now. I saw a CNCF talk at a conference called DevOps is dead, platform engineering is the future. We've got I think, a term that you've helped coin, the concept of internal dev platforms. We've got developers saying, GitOps is just a methodology, it's not an actual thing. Where do you land on this? Is DevOps dead?
The idea behind DevOps is not dead, and it's unlikely to die anytime soon. Point number one. Point number two, most of the companies completely misuse the ideas behind DevOps, right? Because in my head, and my head might have a completely different opinion than everybody else's, DevOps is about joining development and operational knowledge into a team that can deliver application from beginning to the end, right? I don't believe in existence of DevOps engineers because I think that the job is the same as before. Oh, I was managing Jenkins before, now I manage it by I'm called DevOps, right, engineer or something like that, right? So it's a cultural shift. How can we have, what you guys at AWS coined, 2 pizza teams, right? Teams, small teams that can deliver application from the beginning to the end. And now comes the problem. How to do it, right? Because one option is here's a credit card, do it yourself, use AWS, use whichever other services you might want to use. That's never leading anywhere because you cannot have 5-6 people who know everything about everything. You need experts in certain fields. And those experts before traditionally react to Jira tickets. Give me this, I give you that, right? Now we're talking about building platforms so that those experts can convert their knowledge into services that those teams can consume and say, okay, so I need a database, right? I'm doing both development operations. I need operational database, but I really don't know all the intricacies of a DBA. That's why I consume a service created by DBA, right? And the last thing I will add, platform engineering is not a new thing. Every single company I've worked with that is bigger size since last 30 years had some form of internal developer platform. We didn't call it like that, right? There were always teams that help others. It's just that we have now, I think, better tools and better idea how that should look like. It's not something that was born recently.
I think we're operationalizing teams in a way that one ops engineer can now handle much more than in the past. And these tools are really what's facilitating that because, for example, this flow that we've described, it's not really just to support this one dev and what he wants. It would be to support he or she. It would be for whatever that person and all the different teams within a company and then their developers want to build and deploy as well.
And there will be, in creating those services, we should have many different personas jumping in because if we add security now to the mix, there is a strong chance that whomever is really familiar and very good at setting up EKS and RDS is not really an expert in security. So kind of it's teams churning their experience into that platform. So if I modify those, in this case, compositions like this, and create a new release of those compositions that others are going to consume, then we can have actually secure EKS, right, to say something.
Which brings up a good point and kind of a good mental model for goals around an internal developer platform where people involved are all using their experience and they're in charge of the piece that they're good at. And we're not duplicating effort in places where, or like having to learn things outside of that area of our expertise.
Right, exactly. So clearly we have a separation of responsibility here. And if I were to just draw this dotted line, it would kind of go through the dev platform here. But the idea here is this is, just to kind of simplify it, this is ops land, right? This is something that the dev necessarily doesn't need to know. It's a technical implementation detail. And here we've kind of got where the dev really wants to focus. It's what they want, working with Git, making their deployments. Of course, everyone's a stakeholder in actual state. Everyone wants to see what's happening here. You know, we covered a lot of great topics today. Honestly, I think I would like to just keep going with you guys. I think there's still so much for us to cover. We might have to do this again, but we are running out of time. For the folks at home, be sure to catch Viktor's show on DevOps Toolkit. And Viktor, honestly, you're on like 4 different channels now. So just look him up. He's got a lot of great content that he creates. Whitney Lee Enlightening is her show.
Do you want to hear the end of my joke, Sai?
Oh, okay. Is it appropriate? Don't get me banned on Twitch now.
What's brown and sticky? A stick.
Okay, there you go. All right.
He started sweating. I saw him. There was sweat down his face.
I was so Oh man. Okay. I love it. All right, folks. You know where to find Viktor and Whitney. Guys, thank you so much for coming on the show. I think this was kind of an excellent overview. And somehow, Viktor, you managed to fit the demo in as well. For viewers back home, you can always catch the recording on youtube.com/containersfromthecouch. Thanks again for joining, folks, and we'll catch you next time.